Hey there, I'm just going to do a quick demo of some of the critical features of ImageJ or Fiji that you'll need to do the problem set. And thanks for suggesting this because it'll save you some time. So the first thing we're going to do is we go to our applications and look for, when we download ImageJ, it'll come either as ImageJ or as this package Fiji. They're both the same, essentially. It'll launch on your computer, and it gives you this little control bar at the top. A lot of these symbols are pretty self-explanatory, but we'll go through a few of them. And then we can go to the Finder, and here's the files that we're going to use in homework 1. So because they're DICOM files, Fiji will just read them. They have a header, and you can just grab it, bring it into the Fiji like so. And now you've got an image that you can make measurements from. The first thing you might want to do is place a region of interest on the image. And so here's how you can select the oval or ellipse and just open it up, and you can adjust its size after making it. You can make it more elliptical, horizontally or vertically. And then you can move it around to the region of interest. So if we want to look at the histogram of these pixels in the background, just what are the values of these pixels, come up to the Fiji toolbar up here and just say Analyze, click that down, and let's do histogram. And histogram will give you just that. Here's the minimum value, -116, the maximum is 298. It has a bin width, and it shows numbers of pixels in those bins. There are obviously too many bins, perhaps, for this histogram, so you get these blanks in here. So if the bin width got a little broader, these blanks would go away. There is also a way to list these values in the bin. So if you just click list, it brings up this menu, and it tells you the value, the bin start. So this bin goes from -160 to -158.2.11 in terms of pixel values, and the number of pixels that are in that bin, the 0th bin down here. And then as we go to the middle of the histogram, here we can see at 127 around here, we're getting more counts inside these bins. And so you can see there's some kind of artifact created by the fact the bins are a little too narrow. But it gives you a nice picture of the sort of breadth of the pixel values in this field. And it gives you the statistics. So the mean value here is 86, and the standard deviation is 57 in this background. And that's using 9,000 pixels inside this field of view. And so that gives you a nice, easy way to measure, say, the standard deviation of the background. We know it's 57. The mean of the background is 86. We can move, if you turn this on live, I'm not sure it's going to do it, you can move it around and the values will change. Let's make it a smaller field of view here, and then we'll move it such that it includes some of these dark circles. When we go back, we now see we have values down around -1,000. -1,000 in this is a CT image, is air. And if we look at this area up here, when I put my cursor over a pixel, it will give the actual value of that pixel. Here it's -936. And in the background here, it's 77. See, -936 and 77. And so you can look at individual pixels that way. Here we're looking at all of the pixels inside this circle or ellipse, and you get a primary Gaussian for the background pixels that we just saw. And then these dark ones have all of these values in here. Another interesting analysis technique, and you can copy and paste this stuff and just copy it and put it into Excel or whatever you want to put it into, whatever you like to analyze things in. Another thing we can do is select a line. And actually before that, let's magnify. So this is the magnifying glass, and we can go in and place it on a pixel, and just every time we click, left click, it'll zoom it up. And then on the Mac, you say command click, and it goes back, and click comes up. Now let's select a profile, and you can draw a profile through these points here, and analyze, and this is plot profile here. So we do that, and that gives us, I guess I've got the option on to actually print out the points as well, which is probably on some of these options here. But here's a graph of the profile as we move along in pixel units, in millimeters. Remember, in these DICOM images, in the header of the image is some information about the actual dimension of the pixels. And so these plots can be in actual millimeters. And here we see maximum, minimum, maximum, minimum as we go across and take that plot. This can also go live, so that if I move this around, the plot changes, which is really cool. We can center it up right there. So now we know the center of our plot. This point here is this one, right? I've got 1, 2, 3. It should be the middle. It's this one actually, sorry. The dark spots. So I've got 5 dark spots. 1, 2, 3, 4, 5 here, and that's the middle one. Again, I can come in here. I can select these data, go to the end, shift, select, and then just copy that data and go, say, over to Excel, just as an example, and then paste it, and then the data's in here. You can do whatever you want with it in this, or you could read it into MATLAB if you wanted to do that, okay? Now going back, I'm gonna go to magnifying glass again. Oh, the little hand means you can drag the image around inside your magnified field of view. Let's go back to magnifying glass, and we'll hit Command left, 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 and we go back to our view like this. What else do we want to do here? You can just try all of these things that you want to try, and here there's a lot of filters and things like that. But mostly what we're going to do is plot profile, histogram, measure, things like that. In process, you can filter your image with all of these spectacular filters. If we have a stack of images, we can also convert that stack into a movie and things like that, but I don't have a stack of images for this example. So that's a quick way to get started. I think I've given you everything you need to use for the homework. And so, have fun looking at all you want to look at with this program.